Are you interested in getting a job in the data science industry? Maybe you possibly forgotten some very popular machine learning concepts and just need a quick refresher? Are you prepping for a data science interview and you're just sort of worried about what type of questions they may pose to you? Well, look no further. I'm going to go over the basic machine learning concepts and answers you should definitely know when applying for internships or entry-level positions in the data science industry. The questions are definitely related to like the behavioral technical oriented type of an interview, so there's no coding involved. It's more so just general concepts and how deep you understand a specific machine learning algorithm. In many situations, you will be asked to describe the process of many different popular machine learning algorithms. Since this video is tailored for the folks who are still in college, age 18 to 22, I'm going to go over the fundamental machine learning algorithms you should definitely know when interviewing for a data science oriented job. One of the interview questions may be asked like this: explain X algorithm, or in scenario Y, what model would you use and why? Or tell me about your favorite algorithm and why. Note that when you are in the interviewing process, understanding the math and key assumptions behind these algorithms is a huge plus. And when it comes down to preparing for these interviews, you just have to grind the process out, rooted in memorization. I'm not going to go too much into detail on what these algorithms entail, but I will provide a high-level overview to get you started. You're going to want to know the basic regressions such as linear and logistic regression. These are a must. This will introduce you to the world of data science. You will use linear regression for regression type problems and logistic regression for classification type problems. They both have linearity assumptions, but linear regression relies on continuous variables, whereas logistic depends on discrete variables. Also, make sure to check up on minimization of least squares and maximum likelihood estimation and the general theory behind linear and logistic regression. Furthermore, you want to be aware of the applications of penalized regression, such as ridge, lasso, and elastic net. These are useful when it comes to eliminating potentially useless or redundant features in your data, providing more reasonable predictions when it comes to under or overfitting your data. These concepts also introduce the idea of penalization, which is a huge component in more advanced machine learning algorithmic concepts. This also segues into dealing with dimension reduction techniques. So knowledge of principal components is a must. But, factor analysis is an option as well, but definitely not needed to know for an internship or a job fresh out of college. What happens when you have unlabeled data and need to find a pattern? Well, the first base model you should definitely check out is k-means clustering. This introduces you to the idea of what clustering is and how you can find the innate relationships amongst different features. This algorithm will help you classify groupings of observations and in turn can help you label data. So knowing this algorithm down pat is a must. So let's say the situation brings up that you have thousands of features with labeled data. What type of model would you use in this particular use case? You can't really use the traditional type models of where you have like a logistic regression and trying to find the relationship amongst the variables, since you have so many different features. So you should definitely bring up the idea of support vector machines. The beauty of this method is that it uses kernel functions to essentially look at the observations in a different axis to map the boundaries discerning one group from the next. This is a really powerful method for classification related problems, and this is also widely used in industry, especially related to natural language processing. So if you can explain the algorithm at an algorithmic level, you are golden, and this will definitely impress your interviewer. Now, if you really want to impress your interviewer, granted that you are familiar with the other models and the various assumptions that mathematics associate with them, then you can introduce the topic of decision trees and covering topics such as bagging, stacking, and boosting. Although you probably don't need to know stacking or boosting in depth, as it is not really required at that particular level, if you demonstrate your knowledge of these capabilities and the intricacies involved with building and pruning a tree, or hundreds, thousands of trees, you will most likely surpass many of your colleagues in the interviewing process. I hope you took notes on which models to look out for, and even better yet, I did an applied video on each of the concepts I mentioned, so feel free to peruse through my video portfolio. What does it mean to overfit, and how do you address overfit? Overfitting is when you have low bias but high variance. When you are training your model, sometimes you're iterating too many times or you just don't have enough data to train on. So thus, your model will inherently memorize the training data. Thereby, when you attempt to predict the outcome of a test observation, your prediction will be way off and your variance will just be really high. So similarly, underfitting is high bias and low variance. This is when your model failed to model any good relationships on the training data, and you'll more or less likely need more quality data or just more iterations, or even better yet, a different model altogether. So what do we do about that? There are a variety of techniques that we can actually utilize in order to handle the overfit. One of these is using cross-validation. K-folds is essentially where you have let's see, K splits of your data sets, and K minus one of those splits will be used to train your data set, and then the odd one left out is used to actually test your data set, and it keeps on doing this, just iterates through all of those separate folds. Another way is to use a version of penalization. This could be a variety or a mixture between lasso or ridge techniques, where you are essentially squeezing out your coefficients to either go to 0 or approach 0. And this can be, a mixture of both of these techniques, and that is known as the elastic net. And you can utilize those techniques to try to essentially squeeze out your unnecessary variables and make your overall model more concise. This can actually address that overfit issue. And this is the last tricky-ish question. And if you can answer this question, you can probably do very well on any data science interview. But can you describe the process, the mathematical process, I should say, of a neural network? Okay, so assuming that you already have your architecture already all set up and working, and you have all of your observations are already at the go, there's going to be two main steps that you want to be aware of, and you can probably explain at a very high level. First step is going to be the forward propagation. Second step is the back propagation. So let's go over the forward propagation. So here, I find it a lot easier to utilize code demonstrations to explain the architecture of a basic neural network. So I'll start off with this forward propagation part right here. So all it's essentially doing is that it's passing in matrix multiplied outputs into an activation function, and it keeps on doing this throughout the entire neural network. So as you can see here, we're just doing a lot of dot products. We have some biases hidden within each of these layers. However, we just keep on passing in the various outputs and put them into the sum activation function. In this case, it's sigmoid. You keep on doing this for each one of your layers and for each one of your components within that layer. Next step is the propagation part here. So this is a little bit more tricky, and this is like a loose term. In this case, I'm also including the gradient descent and also updating the parameters within the entire architecture itself. So over here, once we have finished the forward propagation to calculate some output value, we then want to calculate the error between the true observation and the predicted observation, and that's done over here. And then we take the derivative of each of the activation functions. In this case, all of my activations were sigmoid, and so just do that for each one of your layers. In this case, I only have one hidden layer and one output layer. So calculate the derivatives for each one of your activation functions, pass in your given output into your given layers. And so hidden layer activations is over here. So these are like the outputs for each one of those layers. You pass them in, and that is your gradient value. Then you want to calculate the multiplication between your error and then your gradient output layer over here. And then you're going to be using both of these errors to then update the weights. So you can see over here we have a bias weight and the outer weight, and it's just being updated of where we're just adding the increments where we multiply the learning rate by the activation dot product, the actual output for that given layer, and everything's being updated as it back propagates. And then it just continues on with however many epochs that we have with that given neural network, and that in itself is the basics of a neural network. So of course, that is the broad level of instructions / questions that you're going to be asked within a data science interview. Of course, you're not going to be asked many of these questions, maybe none of them at all. However, just knowing the answers to many of these commonly asked questions will definitely be useful. And in many cases, many of the questions that I've provided in this video are pretty advanced. So if you do know the questions to those, you're gonna hit that data science interview out of the park. So if you like what you saw, make sure you leave a like, hit that subscribe button if you want to see future content like this. And if you made it to the end of this video, thank you guys so much. And I hope to see you in my next one.